I'm trying to implement the silicon carbide MOSFETs into the DC-DC converter of electric vehicles. My ultimate goal is to improve the efficiency and power density of those converters in the electric vehicles. So actually right at this moment, I'm working on the second generation Cree MOSFETs. So I'm testing them to see the switching characteristics, sort of comparing their losses in different arrangement, like hard switching, soft switching arrangement. So if I see the advantage of soft switching, I'll go for a soft switching topology for my converter. If I see that there is not a big difference in losses in hard switching and soft switching, then I may go for a hard switching topology to sort of control the converter in a simpler manner. And so that's my initial plan, to test those silicon carbide ones in a sort of kilowatt range converter. It's actually the DC-DC converter in the main powertrain of the electric vehicle. And then my next plan is to sort of replace those silicon carbide ones in a sort of similar rated gallium nitride devices, and to see how much improvement I can do with the GaN devices in my converter in terms of power density and efficiency. Because I've seen their prototype devices, the size of those devices, the rating of those devices, they are amazingly smaller than the silicon carbide ones. So it's like a factor of 10 or 20, so it's like very small, but they are running at very high voltage and with a substantial amount of current. So that's just amazing. I'm just waiting for the technology to be matured. By this time I do my converter design with the silicon carbide. I hope that the technology will be matured. I'll get some very good devices, and I can just use them in my converter to sort of get the power density and efficiency.